This video then is going to look at our first shape geometry. There's a lot of shapes that we have to know, rules associated with them, terminology. It's probably less difficult in the way of working out processes, but you have to be able to apply these to diagrams. And although a couple of the rules are provided on an exam paper, I would recommend learning them all with the terminology. First of all, then we're going to look at triangles, but before we go into them and what they are in depth, it's is an important little part of a diagram that you should remember. You'll see these little strokes running through the side of a shape. If there's the same number of strokes, then it means the length of those two sides are the same. So the case of this triangle, this side over here has one stroke going through it. This side over here has got one stroke going through it, so they are the same length. Whereas the one down the bottom has got two strokes going through it, so it's a different length to the other two. Now, this can be used with any shape. It doesn't have to be a triangle, so important to remember that. And another important thing is that if there are no strokes, if there are no rules or evidence that proves a particular length, a blank side cannot be assumed to be a length because it's similar to something else or because it looks half the size of something else. Another thing in diagrams that's important to remember is how angles look. So angles usually shown by a curved line here, but I've had to do a straight line in this diagram. But it's a little line that joins up the two sides that meet at the angle. And if there are the same number of lines, then those two angles are the same. So these two angles at the bottom are the same size, whereas the one at the top, because there's two lines, it's a different size to them. So the angles in a triangle always add up to 180. This will often come up in exams in diagrams where you have to work out angle sizes. And remember, this can be incorporated into a large diagram. It doesn't have to simply be a triangle and you work it out. It's very important because if you've got the other two sides, then if we knew the other two angles, I should say, then we can work out the third angle, because when we deduct the two angles by here from 180, we get the third angle. So an important fact to remember. As you probably know, triangles have got three sides and three angles, hence try three angles. But there are four main different types. An isosceles triangle then, where two sides are the same length. So you can see here there's a stroke by here and one stroke by here to show that they are the same length. The two angles where those sides meet the third side, are identical. So if you ever prove that these two angles down here are identical in size, you know it's an isosceles triangle. We've then got an equilateral triangle where all the sides are the same length. So in this case, there'd be the same number of strokes through all the different sides. All the angles are also the same in it, which corresponds to all the sides being the same length. And that means that all the angles are 60 degrees. So if we know that all the sides are the same length, we know that all the angles are 60 degrees, because 180, remember, all the angles have to add up to 180, divided by 3, because we can split it into 3 equal parts, is 60 degrees. Our third type then is a right angle triangle. The right angle triangle has one angle, which is 90 degrees, what we call a right angle. Notice as well that this could be an isosceles triangle as well, because if we have 90 here, then the sum of the other two angles has to be 90. It's got to add up to 180. So if that was 45, this one was 45, we'd have an isosceles triangle, but we'd also have a right angle triangle. Notice as well that it's half a square or rectangle. So when we're working out the surface area of something like a right angle triangle, when we can work out the surface area of the square or the rectangle, we can simply split it into two and we get the surface area of the right angle triangle. The last type is a scalene triangle where all the sides are different lengths. So in this case, you can't assume that this side is equal to this one because there's nothing showing it, there's no evidence, there's no signs. And if there had been 1 stroke, 2 strokes, and 3 strokes, then it definitely proves that it's a scalene triangle. So the perimeter of a triangle, well, simply, if it's an equilateral triangle, we just can multiply one of the sides by 3 because we know they're all the same length. So in this case, if we've got a triangle with sides A, B, and C, because it's equilateral, all these 3 are the same. So I could just simply multiply one of the sides by 3, and I've got the perimeter, the distance around the outside. With an isosceles triangle, then, we can do a similar thing because we know 2 of the sides are the same. We can multiply one of those sides by 2 and then add the last side on, the one that isn't the same length. And then any other triangle, we have to add up the 3 sides. Now, simply put, you can just add up the 3 sides of an equilateral or an isosceles triangle, but it's important to remember these tricks because in a diagram, for instance, if they show you that there's 1 stroke through all the sides in a triangle and they've given you the length of one of the sides, you can't simply add them all up because you haven't got all the sides. Instead, you have to multiply that one side by 3. Area then is different. Area is what we call half times the height times the base. Now the height of a triangle is the distance from its tip straight down to the base at a right angle, and then the base is the bottom of the triangle. So if I multiply half of this height by the distance from here to here, I get the surface area, how much area it covers. One of the exceptions to this rule is, or I suppose it's not an exception, but in this case, in a case of a right angle, we don't have to worry about going from the tip down to the base. We don't have to work from here going to the base down here. We can simply multiply one of the sides by the other side, the width or times the length, if you like, of the invisible square or rectangle, and then halve it. Remember what I said about the fact that a right angle triangle is half a square or half a rectangle? Well, when you're working out the surface area of a square or rectangle, we multiply the length times the width. Imagine this invisible square all around. So by doing that and then halving it, you can find the surface area of the right angle.